All right, so now we have a good idea about what a feature source is. So when we want to create a feature source, what's required? What do we have to do to create our own feature source? Well, it's surprisingly simple. There's only one absolutely required field that's abstract or method, which is the getAllFeatures core. And what you're supposed to do inside of this is that you implement some sort of code that will pass back all of the features in your underlying data source. So for example, your underlying data source was an Access database, and you have a table called cities, which is actually our sample. Implementing getAllFeatures core would basically select star from that table, select all the records, and convert those records into features and pass all the features back. Optionally, it would allow you to also pass back column information, but that's not really that important right now. And all of the other methods and properties can be deduced just from this one method. So let's look at some examples of deduced methods. So you say, well, if I just implement this getAllFeatures core, how would I get the count? Well, it's simple. Our default implementation inside of the feature source that's already provided to you, when you call the getCount, what we're going to do is we're just going to call the getAllFeatures core, and we're going to count each of the features that you return back. Let's say, for example, another one is a spatial query, and you say, give me the closest feature to this point. That's one of the different kinds of spatial queries you can do. Well, our default implementation is to call getAllFeatures core and loop through each feature and find out which one is the closest point. Now, under the important caveat sections, while the getAllFeatures core is the only required override, you're going to find that for really large data sets, our default implementation is pretty inefficient. So, for example, let's say that you had 1 million records in a Microsoft SQL 2008 server, and you only implemented the getAllFeatures core, and someone called the getCount. Well, you can imagine what's going to happen. All 1 million records are going to get fetched from the database. It's going to move back onto the client side, and we're going to loop through each one of them and get the count back. So that's pretty inefficient. And so there are some recommended methods that you override when you start talking about a little bit larger data sources. So let's now talk about what overloads are recommended. We said in the last slide that basically, there's only one that absolutely has to be done. Now let's talk about the ones that we recommend. The first one, and probably the most important, is getAllFeatures inside bounding box core. And what you want to do there is you want to find a very fast and optimal way to get all of the features inside of a particular bounding box or rectangle. And the reason is that inside of our default implementation, we use the bounding box as kind of a filter, as kind of a first pass to get to really exclude a bunch of the records that we shouldn't search through. So let's say, for example, you want to find any polygons that overlap polygon being passed in. Well, what we would first do is we would first call into this getAllFeatures inside bounding box and try to find any feature that's going to overlap with that bounding box. Because once we know either all the overlapping and contained ones, then we're able to basically filter the result set down quickly, and then we can analyze each feature in turn. So the other reason that this is so important is that most GIS data sources like Oracle Spatial, PostGRE, SQL 2008 with spatial extensions, they provide a very fast way to get features inside of a bounding box. So you'll want to override this one for sure. And if you overrode just this one extra method, you would probably get 99% of all the speed increases that you're going to need for your feature source. So this one is critical. The next one is getColumns core. And what getColumns core does is it provides a list of all the columns available in your data source. So let's say that you had a Microsoft SQL 2008 table. If you implemented just getAllFeatures inside bounding box and you implemented getAllFeatures core, then you wouldn't allow the users to access any column data. So in order for users to access that column data that might be in your database, you need to implement this, and you need to just pass back the columns that are available in your data source. The next one is get count core, and you can see why you would want to override this. And what you want to do inside of here is provide a fast way to count the features in your data source. Now in our example that we're going to see here in a few minutes, we're using access. So when we overrode get count core, we're going to do select count from table and basically get the count back that way. That's very fast, very efficient, and actually very easy to do. The next two, open core and close core, are kind of related. Basically in the open core, you want to initialize and cache any of your data source. So in our example with the access database, we're going to open our connection here in the open core. And in the close core, we're going to close that connection. Now, the way that a feature source and a feature layer of structure is that before you call any of the methods on that particular object, you need to call the open. And if you try to, let's say, call a method with it not being open, all of our different methods are going to raise an exception and say, hey, you have to have it open first. And so when you open it, it's your place to create all of your resources that might have unmanaged resources attached to them. And then in the close, you're going to get rid of all those dependencies, and you're going to get ready for serialization. Now, the reason that's important on the close core that you dispose of all the objects that need to get disposed is that we want our framework ultimately for that every object to be serializable, so that we're going to support the cases where you need to go over a remoting boundary, or you want to serialize to save the data to disk, or you want to serialize the data to store in a SQL server in kind of a web scenario. Now, this object is going to be constantly being open and closed, open and closed. So close is a little bit different than in the analog to a dispose, where once you call the dispose, the object's kind of no longer good. It shouldn't be used. In this case, your object should be able to be open and then closed, and then a minute later be opened back up again. So you want to make sure that you write your open and close code to be able to support those kind of scenarios. So now that we've created our feature source and we've implemented the required and recommended overloads, how do we integrate this feature source with a layer? And if you're familiar with Map Suite and have written any code with it, you'll notice that we don't put feature sources inside the map. We put layers inside the map to draw. So you need to think about how we're going to hook these things up. And if you remember, the layer is kind of a wrapper for a feature source. So every feature layer at its core, there's a feature source that drives its data, that gives it its data. So the first thing we're going to do is we're going to create a new class by inheriting from feature layer. So if it was going to be, let's say, an access feature source, then we would call it maybe the access feature layer. Now, we're also going to create a constructor that creates an instance of our new feature source, and it's going to pass in any parameters that maybe the constructor passed to it, and then it's going to set the this.featureSource equal to the new kind of feature source, because the abstract class feature source is exposed on the feature layer as a property. So in the constructor, we're going to create our feature source, and then we're going to set it next. From there, really, everything else is done for you. No code's required. So in the simplest scenario, you could have a feature layer that just has one line of code. The code would look something like this.featureSource equals new access feature source, passing whatever parameters you'd want into it. So it's really easy. Now, there might be some additional custom properties or methods that you want to expose from the new feature source. For example, let's say that I created a new feature source that was against an access database. So since Access has the ability to do SQL queries, but the feature source specification doesn't have a SQL querying capability, I might want to add a new method called SQL query on the feature source, on my new Access feature source. Well, the user, if they only created a layer, wouldn't have access to that. So you might want to, on the feature layer, create a method called SQL query, and then inside that layer, get the feature source, cast it, and then pass through, call that method and pass through the results on out. So that's really all you need to do to to basically match up your feature source with a new layer. And then from then on, really your users, if you ever distributed that, your users are only going to create the feature layer. So if you had an access feature source and you created an access feature layer, users never really go into the access feature source. They go to the access feature layer, and then that gives them all the power right off of that. Now, before we look at the sample code, I just wanted to give you an overview of what it is and what it does. The sample is an OLADB point feature source and an OLADB point feature layer. Because ODB can accept all kinds of different formats, we've chosen Microsoft Access as the underlying data source. One, because it's portable and we can ship it with the sample, and two, because it's a relatively well-known database. In theory, any OLADB data provider should work just as well. So you could reuse these classes, let's say, to access data in a SQL 2000 server, as long as you know what the connection string is for that under OLADB. The data that we're representing in the Access database are world capitals and their names. So I think there's 191 world capitals and their names that's in the Access database. In our sample, we've overridden all of the recommended methods that we discussed earlier. And I can show you when we get into the sample that actually we can comment out all of the recommended ones and just leave in the one required one. And you'll see that it works just as well. It's just if we actually measured it, it wouldn't be as fast. And if we started to add, instead of 191 records, we started to add 10,000, 100,000, then the speed difference would become very apparent. We've also taken the liberty to create a sample form to render the cities on top of some shapefile data of the world countries. So there's a little sample in there. And you can download these from our website. And without further ado, let's look at some code. Just one note is that when you download the zip file that accompanies the video, to compile it, you have to have installed a full or an evaluation edition of any of the Map Suite 3.0 products, and you'll need to add the Map Suite Core DLL as a reference in the project. If you don't do that, it's going to say that you have dependencies that aren't met. But any of the different evaluation or full editions of our 3.0, they all have the Map Suite Core DLL. So, all right, let's look at some code. Here we are in Visual Studio, and I've already loaded the solution. It's called OLADB Point Feature Source. But before we get into the code, I'd like to talk a little bit about the Access database that we're going to be pulling our data from. If we come over here, I've already loaded it as a data connection. Even though we won't be using this data connection in our sample, we can still use it to browse the database. And as you can see, there's one table called cities, and it has an ID, a city name, and an X and Y. Let's take a look at the data. As you can see, we have all of the city names for all the world capitals and their X and Y values. So I think that's all we need to look at for here. Let's go ahead and launch into